in other problems, you need to uncover knowledge, but you are actually not interested in the pattern itself. You are interested in the result seen as a black box. And one of that example in the context of text is called text categorization or text classification. For instance, you want to, let's suppose that you have a lot of historical document that you retrieve from somewhere. And you know in advance that every document or every text that you found belongs to some particular author. Right? So you have thousands of this historical document. And now your problem is that, unfortunately, you found a document which you have no idea what the author is. So the typical problem for you would be to find out, according to the style or the word user, etc., what the author was. This is the kind of application that we can perform with as a text classification task. So that means that we need previous information. This previous information in classification is called training data. Training data means you have to provide previous examples of the classes of the problem. So for your case, I would say this document belongs to this guy, this document belongs to the other guy, and blah blah blah. And the problem is to find the author of a new document coming. That's the kind of task that we can do with classification. But obviously, it's not enough. One of the problems with classification is you provide an input, and the system gives you the class which the document belongs to, right? So you have to provide some class in order to determine where which is the right class for an unknown document, right? But obviously, the problem that we have, as I said at the beginning, is that we can attract a lot of information. We can attract a lot of information which is actually more related with words. In the best case, this information is related with terms. So usually when you look at the web by using Google, usually you provide terms. But most of the people, term and keyword is almost the same. The bad thing is that term sometimes could be a concept, could be a multi-word concept. For instance, the president of Canada, it's the whole concept. I should try as a term, but actually most of the system don't use it or don't try as a term, as a concept, right? So that means that we need more information. It's key dealing with keyword, dealing with even with term is not enough, because we need to understand what the pattern said. That's not an easy way to do it, right? So what we can do for this is to use what I said before is, what about if I try to use some NLP capability? So yeah, but if I got full natural language document, full natural language process, it is not possible. So I could use some sort of, as I said before, information extraction. So I could analyze partially the content of the text, extract information, and then try to analyze this information, right? So the first attempt to deal with this kind of information was proposed by Marty Hirsch. Marty Hirsch is a professor from the University of California, and Marty Hirsch defined what she called the lexico-syntactical pattern. And what she tried to do is try to improve or enhance WordNet. For all of you not familiar with WordNet is a kind of linguistic ontology. It's a sort of tree-like organization. So what Marty tried to do is try to extract information from document and then hypothesize relationship according to the WordNet. Right? How many of you are familiar with WordNet? Yeah. Nobody? Yeah, just one. All right. Let's think about one like a hierarchy of concept. So you have parents, you have sons, you have some specific relationship between son and parent, or parent and son. You have synonyms, you have antonym, etc., right? So she tried to hypothesize this kind of relationship. So the claim was there are some patterns on the text which are actually saying something very important about the relationship between two patterns. I don't have a pen. No? Okay. No, sorry. That's okay. So if you find some fragment of, or some paragraph like that, that text is saying something implicit. It's saying, the text said, wasn't a very good idea. Say, in countries such as Canada, Chile, and blah blah, having something. So it's something several things. First of all, there are some entities named there, but it's not very important. But the thing is not very important for us because we already know that Chile and Canada are countries. But what about if instead Canada appears something like XY? So I have no idea what XY is, but the pattern says that that is a kind of country. So what Marty here does actually is define patterns which actually have to be instantiated. So every time that I instantiate a pattern, I found new entities. And if I find new entities, I have a new relationship. So in this case, if I say something like blah blah blah, such as blah blah blah, I say that is a connection between a parent and a son. For computer scientists, like it's similar to the concept of a semantic net. So I have this kind of relationship like is a kind of or is a or something like that. So at the end of the day, Marty here is able to find what Warren called hyperonym, which is a kind of relationship, a direct relationship between a parent and a son, right? It's a kind of is a or is a kind of relationship, right? But that's the good thing. She is able to find this implicit information, right? The bad point is that she is not able to assess this pattern. It's perfectly possible that I found something in this example that I already knew, so was known. That means that probably it's not going to be very interesting. If I find a relationship between sea and sailor, for most of us, it's not going to be a very, very smart pattern, right? But the thing is, how do I know that that is an interesting or uninteresting pattern? That's the kind of thing that this approach doesn't do, right? Another more interesting approach was proposed by Looney from Universidad of Texas, and actually, like Martin here, actually for those who are not familiar, Warren is a very popular ontology in the domain of information access or data mining and so on. Actually, it's a general purpose ontology and it's free, so that's an interesting point, right? What Mooney did is try to address the problem of how can I assess, how can automatically evaluate the quality of the pattern that I am uncovering, right? Which is a very important problem if you consider that in most of the case you may find hundreds of patterns. And you will say, yes, of course, but they're not all interesting. So how do I know that there are some interesting or some which are not interesting? So what Mooney does is trying to use warning, which is this kind of hierarchy of concept, in order to assess a pattern. A pattern for Mooney is a kind of rule, but the interesting thing is that he used information extraction. He extracted the early experiment was extracting information from Amazon books descriptions, right? So I extract the basic information. For instance, here this rule represents the fact that a document in Amazon whose title is contained daring, love, The synopsis contains something like woman, the subject is romance, historical fiction, and then blah 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 blah. Right? This information is extracted from the book description and from the information left by the visitor. I don't know if you have seen her. You can provide some feedback to some book, something like